Okay, before we can really talk about how to find the area of a parallelogram or a trapezoid, we should talk a little bit about what they are. So starting first with the parallelogram, it's a four-sided, four-cornered shape with straight lines. And you'll notice there's these little arrow type things on there. That suggests these lines are parallel. Now hopefully we've talked about this in class in the future, but for now, a parallel line, they're lines that will never meet. So if these lines kept going forever, they will never touch each other. They'll never, for example, end up going like this. They'll go straight forever. So what's significant about a parallelogram is it is made up of two sets of parallel lines. These two lines would never meet, and these two lines would never meet. A trapezoid is similar in that it is made up of four straight lines, four corners, but this one only has one set of parallel lines. If these lines were to keep going, it's quite clear that eventually they would meet each other. Okay, so when we find the area of a parallelogram, the formula is area of parallelogram equals base times the height. So the base is either the measurement of this or this, up to you. And then we times that by the height. Now the height is from one of these corners to the base, or you could say from that corner up to that base. So here's an example from the IXL practice. We can see that our base, they've given us 5.8 centimeters, and our height from the base all the way to the top. Notice these are the two parallel lines and these are two parallel lines again. Sorry, our height is 9.6. So this is a pretty simple formula. 5.8 centimeters times 9.6 centimeters. Again, I don't mind if you use a calculator here. I'm going to do the math just because it's good practice. 5.8 times 9.6. 6 times 8 is 48. 8 down, 4 up. 5 times 6 is 30, 34. 0 down. 9 times 8 is 72. 2 down, 7 up. 5 times 9 is 45, plus the 7, 52. Add it together. 8, 6, 5, 5. Remembering what we talked about earlier with placement of the decimal, this is really saying about 5 times about 9, so it's going to be around 45. So it makes sense that our decimal goes there. You could also say, oh, there's one digit behind that decimal, a second digit behind that decimal, goes in two places. So our answer is 55.68. Therefore, our answer is 55.68 centimeters squared. Okay, in this next example, I'm hoping you're recognizing already that this is no longer a parallelogram. We have this parallel line, this and this are parallel lines together, a set. But if you look at these other two lines, it makes sense that eventually if they kept going, they would meet. So that means this must be a trapezoid. Okay, so here I've put the formula for how to find the area of a trapezoid. We go A plus B divided by 2 times H. So what do those letters mean? So A and B are the measurement of the two bases. It doesn't matter which one you label A or B. I could have said this was A and this was B, but it's the two parallel parts. The H is obviously the height, so 18 is the height there. If we were in class, I would take more time to prove to you why this works, essentially by adding together the two bases and then timesing it by the height. We're kind of treating it like a rectangle, and then because it's not, we're having to divide it by 2, almost like we did with the triangle. But for now, I'm just going to ask you to take my word for it, and we're going to plug in the numbers. You'll get to see more and more formulas where it is just a matter of understanding the formula, having access to it, and then plugging in the numbers. So we know A and B, we know H, so now we can solve. A is 5 centimeters plus B is 15 centimeters divided by 2 times H is 18 centimeters. So I'm going to work my way through the equation. 5 plus 15 is obviously 20, so equals 20 centimeters divided by 2 times 18. What do I do next? We should do the divided by 2 first, because this kind of looks more like a fraction. So, and it follows again that order of operations. We're moving, remember, multiplication and division are on the same kind of level, and then we just move sort of from left to right, and these come first. So 20 divided by 2 is 10 centimeters, times 18. 10 times 18 is 180. 100, oh, sorry, I forgot centimeters. 180 centimeters, and it's important because here we see the centimeters times centimeters makes centimeters squared, which makes sense because we are finding the area of a trapezoid, and area is always in centimeters squared. Plugging the numbers into a formula is a bit of a new concept for us, so I am going to do one more example very similar. Again, I don't really mind if you use a calculator for this. The math isn't too complicated, but it should make it easier. I want you to make sure you're able to do the steps, that you understand how to solve the problem. So again, I can tell it's a trapezoid because I have one set of parallel lines and the other sides will eventually meet. So I'm using the formula I have in the top right corner here. So area of trapezoid equals a plus b times, or divided by 2 times the height. So I'm going to say this is A, this is B, this is obviously H. So now it's just filling it in. 2.8 kilometers plus 9.2 kilometers divided by 2 times 8.1 kilometers. Okay, I'm just going to do a little math down here. 2.8 plus 9.2. 8 plus 2 is 10, 0 down, 1 up. 1 plus 2 is 3, plus 9 is 12. Remember, decimal in addition lines up. So my answer there is 12.0 kilometers divided by 2 times 8.1 kilometers. So now 12 kilometers divided by 2 is obviously 6 kilometers times 8.1 kilometers. Just move that up a little bit so I have some more space. I'll do the multiplication down here. 8.1 times 6. 6 times 1 is 6. 6 times 8 is 48. Keeping in mind, 8 times 6 is obviously about 48, so it makes sense to put it there. There's also one number behind, so I move one number in. Equals 48.6 kilometers squared. That's our answer. Okay, in this last example, we're using our algebraic thinking to find the variable. So let's start by identifying the fact that I'm hoping you recognize this as a parallelogram. We see there's a set of parallel lines here and a set of parallel lines here, therefore parallelogram. I'm not sure, hopefully you remember, the formula for the parallelogram is pretty straightforward. Area equals, of a parallelogram, equals base times height. So we have our base here, 18, and we have our area. So I'm going to plug those numbers into our formula. 306 meters squared equals 18 meters times height. So we're solving for height. If we want, we could just say E times P, because we're kind of solving for P. I'm going to switch those around just so it's easier to divide by 18, because then we have 306 meters. Ooh, that was messy. 306 meters squared equals P times 18. So if I want to get the P by itself, I need to do the opposite operation to times 18, which is divided by 18. Divided by 18, what I do to one side, I have to do the other. These cancel out. So 306 divided by 18 equals P. I'll do that division here. 306 divided by 18. How many 18s can I take out of 30? 1. 1 times 18 is 18. Minus equals, becomes 2, 10, 2, 1, 12. Bring down the 6. How many 18s can I take out of 126? 18 is close to 20. Probably take like 6-ish. I have to try over here. 6 times 18. 6 times 8, 48. 8 down, 4 up. 1 times 6 is 6, plus 4 is 10. Maybe one more. Let's try... Oops, over here, let's try 18 times 7. 7 times 8 is 56, 6 down, this looks good. 5 up, 1 times 7 is 7, plus 5 is 12. Okay, so we can take 7 out. 7 times 18 is 126, minus equals 0. So to finish off the question, we did this division right here. So our answer is, and notice we've gone meters squared divided by meters. So again, we're kind of like minusing 2 minus 1 is just 1. So it's 17 meters equals P. Okay, good luck with the practice session.